When we think about how science is conducted, we usually think about the scientific method. And you may remember learning about the scientific method at some point in your schooling, but I figured we would review it in case that anyone had any questions. And the first step of the scientific method is usually to start out with some kind of observation or question. And by this we mean that maybe you've observed something in the real world that you find interesting, or you're questioning the why of something. But it isn't enough to just have a question, because maybe someone's already asked it before. And so what you need to do is you need to do some background research before you go any further. And this isn't just any kind of online research, this is research in scientific journals in the field that your question comes from. And I think that this step, might sound easy to skip, but remember that science is not conducted in isolation. But even if you find that your initial question has already been answered, there are usually many more questions that research has generated. And there are always more questions to be answered. After our background research, our next step is to come up with some kind of testable hypothesis. Or a prediction of what we expect to see. So at this point, you've asked a question and you've done some background research to see if anyone else has answered it. And at this point, you've probably come up with some kind of prediction, something that you expect to see. And that's what you need to write in your hypothesis. You want to be able to put forth a statement about what you would expect to see if your predictions were correct. The next step is to develop a method by which you're going to test your hypothesis. And methods are important, and we'll talk about that in future videos, but it can be really hard to isolate what you're trying to ask. So usually a lot of time is put into developing a method and making sure that it's actually answering the question that you want it to answer. Your next step is to actually use that method and to run your test on your participants. And at this stage, it's really important that you conduct your test in a rigorous manner. It needs to be done without any bias, just so you can make sure that the predictions that you have made aren't somehow influencing the test towards the results that you want to see. The next step after that, and I'm running out of room a little bit, so I'm going to move it over to the side, is that you're going to start to analyze your data. And there are a lot of rules for analyzing data. You can't just say that two things look like they're related. You need to actually show it through really rigorous statistical testing. And after you've analyzed your data, your next step is to interpret your data. And note that this is a different step from analyzing your data. And that's because interpretation is different from analysis. And so you always just need to keep in mind that what we say about the data is different from the actual data itself. And an interesting thing about the scientific method is that you may think that it's, not really useful after you've graduated from middle school and don't need to remember it for a test. But actually, scientists use the scientific method, especially when they're writing up their papers. And scientific papers, although slightly different for different disciplines, usually have the same kind of structure. So usually they start with an introduction, where the author will go through all of the background research on the subject of their paper, state a question, and then state their best hypothesis or prediction. After the intro section is a methods section, where, as you can probably guess, they go over the methods that they used for their study. After the methods section is the results section. And this is the section where they actually show you the data that they collected and the statistical tests that they used in order to analyze your data. And this is the part of the paper where you're most likely to see things like different graphs and charts and just ways that the authors are illustrating the data in different ways. And after the results section, you have the discussion section. And this is where you discuss the data. This is where you interpret the data. So you may remember how before I made a distinction between analyzing the data and interpreting the data. Well, we see that distinction here, where in the results section, you talk about what the data is, and in the discussion section, you talk about what the data means and how it might fit into a larger body of research. The discussion is also a place where you can talk about things that might have gone wrong in your study, and also talk about questions that might have come up while you were doing the study, things that show directions for future research. And so there you have it, the scientific method.